Okay, the final part of today is slope, and this is something we're going to use a lot the rest of the year, and I think you'll like it better than the rate of change stuff, but it's really the same thing, okay? So remember, when you have a rate of change, it's the change in dependent variable over the change in the independent variable. For us, or if we're talking about an equation, the dependent variable is going to be the y's, all right? So change in y. Oops, I don't know why my E is so far off there. So change in y over change in x. And actually, the way that we're going to see this for a little bit here is actually called rise over run. Alright, so basically you're looking at the movement of horizontally over the movement of vertically. And we'll talk more about that in a second here. But rise over run is going to be a big formula that we can use the rest of the way for slope. If you think about straight lines on a coordinate system, you have four possibilities. You can have a line that rises from left to right, a line that falls from left to right, a horizontal line, and a vertical line. And what I want to do is explore each of these possibilities here as far as slope goes. Alright, so find the slope of these two lines. Remember, you can use the change in x, or the change in y over the change in x, or rise over run. And that's going to be, like I said, a very common formula here for us. Alright, so you can choose any 2 points that are on your graph, any two that you want, and you should get an accurate slope, okay? Now, they're not always going to show you which 2 points to choose. I like to choose points that are right next to each other. So for instance, I know that this one passes through the origin, and then the point 1, 1 is also on there, okay? So between those 2 points, then I check to see, okay, how far does it rise between those 2 points? Well, it goes up 1, and then how far over do I need to go? I run 1. So my slope will then be 1 over 1. Sorry, I keep switching colors here, just for visual purposes. Okay, and what is 1 divided by 1? Well, it's 1. So this line has a slope of 1, and it is positive. Okay, so if you have a line that rises from left to right, so remember, you always read from left to right, you're going to have a positive slope. All right. So as you can probably imagine, the one on the right here, this goes down from left to right. So as we're going from left to right, it decreases or goes down. This will have a negative slope. Again, we're going to choose any 2 points that we want. I recommend choosing points that are on hash marks. And what I mean by that is, like, for instance, okay, sorry about that. I had some students that needed to see me. Okay, so like I was saying, you want to choose points that are on tick marks or hash marks, meaning, for instance, I know this point is on there, it goes through the origin. The next point that I see as I go this way is this one. That is on 2 hash marks. The reason that's nice is because you're dealing with whole numbers or integers when you do it that way. So for instance, if I looked at, this point is on there, but it's not easy to say what that point is exactly, versus I know this one is 0, 0, and I know this is -4, 3. Okay, so, and you can choose any 2 points that you want to, but remember, we're going to look, okay, how far do I have to run from left to right? So 1, 2, 3, 4. So this is over 4, but then I'm using the wrong color, I guess, doesn't matter. I'll erase that. And then I have to go down 1, 2, 3. So anytime I go down, that's not rising, I'm going to consider that negative. So my rise is -3. And my run is +4. Alright, so, and just color coding again. But I could say my slope is -3/4, or I could say it's negative 0.75 if I divided those two numbers. I'm sorry, I'm going a little over my time here, but I only have these two left. So what happens if you have a vertical line and you have a vertical line or horizontal line? Let's look at the horizontal line first here. Remember, you can choose any 2 points that you want to. So here's my horizontal line. Okay, they have 2 points on there. You don't have to use the ones that they use. For instance, I'll take that one and that one. So one of these points, what is the change in x, which is my run? So remember, we've got rise over run. Okay. But what is it? What's it look like in slope form? Well, we've run over 1, okay, but we didn't rise at all. We're not increasing in vertical movement, so that's 0. Well, if you put 0 divided by 1 or 0 divided by anything, you get a slope of 0. So all horizontal lines have a slope of 0. And lastly, if you look at the 2 points that they chose here, we'll use them this time. Looks like we go, so if we rise over run again, we go up 1, 2, 3, 4, but we don't go anywhere in the horizontal direction. However, if you try to type that into your calculator and do 4 divided by 0, you get an undefined. So this slope is undefined. You cannot divide by 0. That's not possible. Go ahead and try it. It won't work. And you can choose any 2 points and it'll be undefined. So here's our big discovery. We'll talk, I had one more thing to talk about that I'll touch on tomorrow. But we've got 4 types of lines that we can run into as long as they are straight and on a coordinate plane, and here they are. If it rises from left to right, it's going to be 0, or positive, sorry. If it falls from left to right, it's going to be negative. So I imagine a person walking. I always put a person in there. Walking up that would be a positive slope. Walking down would be a negative slope. If you're walking on a flat surface, that's 0, like a treadmill. Okay? An undefined slope would be like standing by a wall with nothing to help you climb up it. You're not going to climb up this thing without any help, so we call that undefined. Alright, sorry I went a little long on this one, but that's all I've got. We'll talk more about it tomorrow. Alright.